Continuation of Pure Maths Paper 1, June 2018. I already solved question 1 to 10 in other videos of Bond Maths revision. So in this video, I'm going to continue from question 11 upwards. We are required to look for the limit of this function as x tends to minus 2 and choose the right answer from option A to D. To find the limit of a function, we need to first of all simplify the function. We need to factorize the numerator since the numerator is a quadratic expression. That is, we look for factors of minus 6. When we multiply, we give minus 6, and when we add, it's going to give minus 1. That is a coefficient of x here. Those factors of minus 6 are 2 and minus 3. That is x into x. That is, here we write plus 2 and here we write minus 3 all over x plus 5 into x plus 2. That is lim of this as x tends to minus 2. X plus 2 and x plus 2 can cancel. We're left with limit of x minus 3 over x plus 5 as x tends to minus 2, which is the same like minus 2 minus 3 over minus 2 plus 5, which is equals to minus 5 over 3. So the right answer is this, which is B. Sin 4 theta plus sin 2 theta over cos 4 theta plus cos 2 theta is equivalent to what option from A to D? From sum to product formula, we know that sin alpha plus sin beta is equals to 2 sin alpha plus beta on 2 times cos alpha minus beta on 2. That means sin 4 theta plus sin 2 theta is equals to 2 sin 4 theta plus theta all over 2. That is 4 theta is the same like alpha and 2 theta is the same like beta times cos 4 theta minus 2 theta over 2, which equals to 2 sin 3 theta. Since 4 theta plus 2 theta is 6 theta divided by 2 is going to give 3 theta times cos theta. Since 4 theta minus 2 theta is 2 theta, 2 theta divided by 2 is theta. From sum to product formula, cos alpha plus cos beta is equals to 2 cos alpha plus beta over 2 times cos alpha minus beta all over 2. That means cos 4 theta plus cos 2 theta is equals to 2 cos 4 theta plus 2 theta all over 2 times cos 4 theta minus 2 theta over 2, which equals to 2 cos 3 theta. Since 4 theta plus 2 theta is 6 divided by 2 is 3 theta times cos theta. Here the numerator will be this, that is 2 sin 3 theta cos theta all over the denominator, which is this, that is 2 cos 3 theta cos theta, which is equals to sin 3 theta over cos 3 theta. Since cos theta cancel cos theta here, 2 cancel 2 here, sin 3 theta over cos 3 theta is equals to tan 3 theta. Tan 3 theta is option A, that is this one. Number 13. Given y equals to 1 plus 2x to the half power, dy dx will be equals to option A, option B, or option C. Let's find out. This is a composite function. That's a function of a function. Differentiate this kind of function, we need to let u equals to this function in the bracket. Let u equals to 1 plus 2x. You know, if y equals to x to n, it means dy dx equals n x to the n minus 1 from the differentiation formula. That means from here, du dx is equals to 0 plus 2, which is equals to 2. Since the differentiation of any constant is always 0 and the division of 2x is 2. That means du is equals to 2 dx. U is equals to this. It means y equals to u to the half. Dy du equals to half u to the half minus 1, which is half u to the minus half. But du is equals to 2 dx. That means dy over 2 dx equals to half u to the minus half. Multiplying both sides by 2, this 2 we cancel. I'm going to have 2 times half u to the minus half. 2 cancel here, I'll have u to the minus half. But u was equals to 1 plus 2x. Therefore, 1 plus 2x to the minus half, which is this one. That's option B. Number 14. The integral of 3x over 1 plus x squared dx is a, b, c, or d. You know, the integral of f prime of x over f of x dx is equals to ln f of x plus c, the constant of integration. You know, if y is equals to f of x, then dy dx can also be denoted as f prime of x. Now the integral of 3x all over 1 plus x squared dx is equals to 3 into x all over 1 plus x squared. The constant can be sent out like this. You know, if we differentiate the denominator here, we are going to have 2x. So it means that for us to apply the ln formula, we need to have 2x in the numerator. That is 3 integral of x over 1 plus x squared times 2 over 2. You know, 2 over 2 is the same like 1 dx. So I have not change anything, it's still the same like this. So we have factorized these 2 in the denominator outside. I'm going to have 3 on 2 integral of 2 times x, which is 2x all over 1 plus x squared dx. That means 2x at the numerator is the differentiation of the denominator according to this formula. That means I can write now 3 over 2 ln 1 plus x squared plus k, the constant of the integration. The right answer is this one, which is D. Number 15, a real-valued function f is defined by f such that x map to 2x over 4 minus 3x, where x belongs to the set of real numbers and x is not equals to 4 on 3. The range of f is which of the options below? Let's find out. The range of a function denoted grand f is always equals to dom f inverse. It is a formula. To look for f inverse, let y equals to 2x all over 4 minus 3x, this function, which is this, and then we make x the subject of this equation. That's y into 4 minus 3x is equals to 2x all over 4 minus 3x times 4 minus 3x. That is y into 4 minus 3x is equals to 2x, since this one cancels out. Now expanding this, we have 4y minus 3yx minus 2x, as 2x comes the other way, which is equals to 0. X is common in these two terms, so we factorize minus x out. We're going to have minus x into 3y plus 2, which is equals to minus 4y. We're dividing both sides by minus 3y plus 2. We have x will be equals to 4y over 3y plus 2. From here we conclude that f inverse is equals to 4x all over 3x plus 2. Now we look for dom f inverse. To look for the domain of f inverse, set the denominator to be equals to 0. That is 3x plus 2 equals to 0. And then we look for x. From here, x is equals to minus 2 on 3. Dom f inverse will be equals to the set of all x belonging to a set of real numbers such that x is not equals to minus 2 on 3. So I turn my equal sign here to not equals to. That is, the right answer here is this one, which is option B, number 16. The range of real values of x for which the inequality x minus 3 all over x plus 2 is less than or equals to 0 is A, B, C, or D. Let's find out. To solve this kind of inequality, we let the numerator x minus 3 equals to 0, and then we look for the value of x, which is equals to 3. Also, we let the denominator x plus 2 equals to 0, and then we look for the value of x, which is equals to minus. Now, there are two values of x, minus 2 and 3. These two values are called critical values. We represent them on the number line. That is 3 here, minus 2 here. On the number line, positive numbers are on the right side of 0 and negative numbers are on the left side of 0. That's why I put minus 2 here and 3 here. Now, there are three regions on this number line. The region below minus 2, the region between minus 2 and 3, and the region above 3. So we take a value in each of these regions and test whether it satisfies the inequality or not. For a value to satisfy this inequality, the value must make the inequality less than or equals to 0. Between minus 2 and 3, let's choose 0 and test in this inequality. That is, for x equals to 0, we have 0 minus 3 all over 0 plus 2, which is equals to minus 3 over 2. Minus 3 over 2 is less than or equals to 0. Therefore, this region is negative because it's less than or equals to 0. Let's choose 4 in this region. That is, for x equals to 4, 4 minus 3 over 4 plus 2 is equals to 1 on 6. 1 on 6 is greater than 0. That means any value chosen in this region will give positive results. Let's choose minus 3 in this region. That is, x equals to minus 3. We substitute minus 3 in the place of x. We have minus 3 over minus 3 plus 2, which is equals to minus 6 over minus 1, which is equals to 6, which is greater than 0. It means any value taken in this region will make the inequality positive. For the inequality to be satisfied, it must be less than or equals to 0. And the region in which the inequality is less than or equals to 0 is the region from minus 2 to 3. That is, for all x in this region, x less than or equals to 3 and x greater than or equals to 2. Going through the options, I am not seeing this interval, but minus 2 less than or equals to x and x less than or equals to 3 is equivalent to minus 3 less than or equals to x less than or equals to 2. Since when we are multiplying an equality by a negative sign, the inequality sign always changes. The correct answer here is D, number 17. The vector equation of a straight line is r equals to 2i plus j minus 2k plus t into 3i plus 2j plus 6k. The direction cosines on the lines are a, b, c, or d. The vector equation of a line, say r, is always equals to the form a plus lambda d, where a is the position vector, lambda is a scalar, and d is a direction vector. So comparing this equation with this formula, it means the direction vector is this one. If the direction vector is equals to, let's say, mi plus rj plus sk, then the direction of the cosine is given by the formula m over mac d, r over mac d, s over mac d. That is the direction vector. Here the direction vector is 3i plus 2j plus 6k. Mac 3i plus 2j plus 6k is equals to the square root 3 squared plus 2 squared plus 6 squared, which is equals to 9 plus 4 plus 36. That's square root of 49, which is equals to 7. It means the direction cosine are 3 all over 7, 2 over 7, 6 over 7. And then the right answer here is this one, which is D. Number 18. Given the parametric equations x equals 2t plus sine 2t and the y equals 2 minus cos 2t, where t is the parameter, dy dx equals to, the first thing to do is to differentiate the parametric equation with respect to t. That is, dy dt is equals to 0, since differentiation of 2 is 0, plus 2 sine 2t. You know, when we differentiate cos t, we always have minus sine t. And when we differentiate sine t, we have cos t. And when we differentiate cos f of x, we have minus the differentiation of this function, which is f prime of x, and the differentiation of cos f of x, which is sine f of x. That's minus sine fx. Also, when we differentiate sine f of x, we have f prime of x cos fx. That is why I have plus 2 sine t here. That's when we differentiate f of x here is like 2t. That's our f of x here is like 2t. When I differentiate 2t, I have 2, and then differentiating cos 2t, I have minus sine 2t times the minus here, it becomes positive, which is the same as 2 sine 2t. dx is t will be equals to 2 plus 2 cos 2t. Following this formula, dy dx can be written as dy dt times dt dx, because when I cancel dt, I'm still going to have back dy dx. So it's just a way of writing dy dx in terms of dy dt and dx dt. But dt dx is equals to 1 over dx dt. That is equals to 1 over 2 plus 2 cos 2t. That is, dy dx is equals to dy dt, which is 2 sine 2t times 1 over 2 plus 2 cos 2t. That is, dy dx is equals to 2 sine 2t all over 2 into 1 plus cos 2t. That's I factorize 2 out, and then the 2 here, cancel the 2 here, and dy dx will be equals to sine 2t all over 1 plus cos 2t. The right answer is this one, which is B. Number 19. The general solution of the differential equation cos x dy dx is equals to y sin x is which one of the following? Let's find out. This differential equation is a first order differential equation which can be solved by the method of separation of variables. Multiplying both sides by dx, I have cos x dy is equals to y sin x dx. Since when I multiply this one by dx, dx is going to cancel here. Now dividing both sides by cos x and y, I am going to have dy over y is equals to sin x over cos x dx. Now I integrate this side with respect to y, and I integrate this side with respect to x. Recall that the integral of f prime of x all over fx dx is equals to ln f of x plus constant of integration. That means if the function at the numerator is the differentiation of the function at the denominator, the integral will be the ln of function at the denominator. From here, we can see that this integral can also be written as 1 over y is equals to sin x all over cos x dx. The numerator here is the differentiation of the denominator. It means this side can be integrated as ln y. When I differentiate cos x, I have minus sin x, but I need to have minus sin x in the numerator so that I can take the ln of cos x. So to do this, I can put minus here, and if I put minus here, it means I also have to put minus down, so that minus over minus will cancel. But I don't need minus down here, so I can remove the minus out here. So if I factorize the minus out, now I have cos x down and minus sin x at the numerator. It means I can conveniently now apply this formula. That is, ln y is equals to minus ln cos x plus the constant of integration k. This is the same as option D. Number 20. 1 minus I all over 1 minus 2i is equals to which option from A to D? Express this complex number in any of the following forms. We need to multiply the denominator and the numerator by the conjugate of the denominator. That is 1 minus I times 1 plus 2i all over 1 minus 2i times 1 plus 2i. You know, if z equals a plus ib is a complex number, it means the conjugate of z is equals to a minus ib. That's between the real part and the imaginary part. We write the opposite of the sign. Here is plus, write minus. If it was minus, write plus. You also know that z times z conjugate is equals to a squared plus b squared. That is 1 times 1 plus 2i minus I times 1 plus 2i all over 1 squared plus 2 squared is equals to 1 times 1 plus 1 times 2i, which is 1 plus 2i, minus I times 1, which is I, minus 2i squared, that's I times I, all over 1 squared is 1 plus 4 is 5, which is equals to 2i minus I is I. You know the square root of minus 1 is equals to I. It means I square is equals to minus 1. I square here is minus times minus is plus. It means 1 plus 2, which is 3. It means 1 plus 2, which is 3 plus I all over 5, which is the same like 3 on 5 plus 1 on 5 plus 1 on 5 I. This answer is the same like this one, which is A.